My name is Ernest Braxton. I'm a neurosurgeon practicing out in Vail, Colorado. Prior to that, I was the chief of neurosurgery for the Air Force down in San Antonio. I spent 10 years in the military serving in tertiary medical centers. So Vail Summit Orthopedics and Neurosurgery is a 13 physician group practice specializing in musculoskeletal care. We have sports medicine, joint reconstruction, spine surgery, as well as physiatry and rehabilitation. We did an exhaustive search, trialing and looking at other systems. And at the end of the day, one of my concerns was, what is the long-term durability of the product? What if the technology shifts or moves? Will this still be competitive? Will this still meet my surgical needs for my patients? The fact that the GE OEC 3D is open source, it means that you can apply it to many different types of implants and technologies, and they marry together very well. This gives me as a surgeon a lot more options when discussing particular problems with a patient. The OEC 3D has really been a game changer in my practice. We use them for artificial disc replacement surgery, both in the cervical and lumbar spine arthrodesis or spine fusion operations, as well as discectomies and laminectomies, as well as neuromodulation cases where we're implanting spinal cord stimulators. It really takes the place of a traditional C-arm because it does everything that a traditional C-arm does, plus it can render 3D reconstructed images for more precise localization. One of the more challenging cases we do is localizing in the thoracic spine. We don't have the same landmarks like you do in the cervical spine or lumbar spine, and when I'm doing thoracic procedures, I find the OEC a must-have. In fact, we make it a note that needs to be in the room or we don't do the case. Having the larger field of view and being able to get a 3D reconstruction when you're in the thoracic spine is really critical and kind of made the operation a lot safer. It's got a much smaller footprint, less radiation exposure. We're not leaving the room for the what we call a spin or a 3D reconstruction. And oftentimes, if it's not necessary to do a 3D reconstruction, we use it as a conventional C-arm, but just with a much larger field of view. My first impression is I thought it was a conventional C-arm. I didn't realize that it had the ability to obtain 3D reconstructed images of the spine for surgery at a high rate and easy rate. It offers different methods of acquiring the specific anatomy. It has features that I wasn't used to having but found to be invaluable, like the camera feature and also the laser feature. Image quality has really been superior, both in the image quality itself and the large field of view. So a perfect example is a case I did last week. It was a neuromodulation case or a spinal cord stimulator case where precise localization of where your leads are in place is critical to the outcome of the surgery. With traditional C-arms, what we have to do is take a shot and then move the image along as we're driving the lead along the spinal cord. The one thing that has changed our workflow in a couple ways is when I was using the incumbent devices and getting 3D images, oftentimes it would take at least 20 minutes for us to get those images. And a lot of times we would skip the post-op spin just because of radiation exposure to the patient and added surgical time. With the OEC 3D system, we get pre and post-op spins on every case because the imaging is superb, the timing and efficiency is quick, and the radiation exposure is less. So the question is, why wouldn't you get a second spin? When placing an artificial disc, unlike a conventional fusion operation, it's really important to know exactly where you are and to be precisely in the midline and to make sure that the prosthetic fits the patient perfectly. Having the ability to get a 3D spin, we're able to get better matches between the prosthetic and the patient and know before we leave the operating room that the device is positioned perfectly to do its job. It's augmented what we already are capable of doing, but at the end of the day, we really need to know in real time where we're at anatomically. Navigation provides us a picture of the spine, in my case, 20 minutes or an hour ago. And so when I need to refresh that, getting a new spin or refreshing that image can be done in less than 3 minutes. I think having this product has given me more confidence to do complex procedures in the ASC. We're able to check the location of the instrumentation prior to closing, knowing that it's going to be as good or better than had it been done with a more conventional system. And because of the efficiency, it's allowed us to do more cases. You can do what you want with that extra time. You can have more time with your family, or you can have more time to do more cases. But it has definitely produced more time because of its efficiency. One of the first things I noticed when comparing the GE OEC to other incumbent cone beam CTs or 3D CTs is the smaller footprint and the speed of image acquisition and decreased radiation exposure both to the patient and to the surgical team. My favorite feature is the memorization feature. When I line up a view to a pedicle or a specific part of anatomy, I'll tell the technician to save that shot, save that position, and then I'll go to another position, and then the technician can automatically go back to the last position very quickly and easily. That is one of the biggest frustrations that we have, is finding that last view that we had 10 minutes ago. I was a little concerned about not being able to physically move the gantry around the patient and the learning curve that it would take for the technologist and myself and our surgical team to use the device. But I found there's a lot of advantages to having a motorized gantry. Being able to memorize certain positions and coming back to those quickly and efficiently has really made my operations much more efficient, decreased surgical time and anesthesia time for the patients. If there are surgeons who have reservations about considering the OEC 3D, especially in an ambulatory surgery center, I would highly encourage them to do a trial of the device to see if it meets their needs for image quality. I think they'll find that it's a fiscally responsible decision. It is a lighter footprint, smaller device to use in sometimes crammed operating rooms that you see in surgery centers. If 3D reconstructions aren't necessary, we still always need to localize where we are with fluoro shots. I can't really think of a procedure where I would not want to have the OEC 3D. We have fully incorporated it into our practice.